Okay, so in this video, we're going to look at the formal definition of an onto function or surjective function. So it goes like this. A function is said to be onto or surjective if for every element y in the codomain, there exists an x in the domain such that f of x is y. F of x means the image of x is y. So for every y in the second set, there should be an x in the first set such that y is the image of x. So in simple layman's language, I could say that every element in the second set should have a pre-image. Yeah. So something like this. So if you look at these two sets here, every element in the second set has got a pre-image. A has got a pre-image 1 and B has got a pre-image 2. So it's onto, but it's also at the same time 1 1 we know, because the every x has got one unique image. Like 1 has got A and 2 has got B. They don't share the same image. Then if 2 had gone to A, it would have been many to 1, but this is 1 to 1 function, and also it is onto because no free elements in the second set. I could say it in many ways. No free elements in the second set. The codomain, the second set, and the range, which is the set of answers, are both the same. Every element has got a pre-image. So different ways of saying. So we say this is both 1 1 and onto, and hence it is called a bijective function. So the two results we learn now. First thing, how do we prove that f of x is 1 1? So if I want to prove that f of x is 1 1, what we are going to do here is that I'm going to assume that there are two images for some reason the same. Like the image of x1 and image of x2 somehow happen to be the same, which means it gives you a feel that x1 and x2, two different elements, are mapped to the same. So that sounds like many to 1. But on further investigation, if you see that actually your x1 and x2 are also the same. So the images were same of x1 and x2, but on further investigation I found that actually x1 and x2 are not two different elements, they are the same elements, which means basically only one element getting mapped to one image. So if f of x1 is equal to f of x2 implies that x1 and x2 are equal, then f is said to be 1 1. So in any question, I need to prove that f is 1 1. What I will do is I will assume that f of x1 is equal to f of x2. Then I'll work on that, I'll simplify that, and then finally if I can prove that x1 is equal to x2, that means f is 1 1. Next is about onto. F of x is onto. If f of x is onto, what does that mean? Every element in the codomain should have a pre-image. So what we do for that is, we'll say let y be any element in the codomain. Then I should look for an x in the domain such that y is equal to f of x. If I am able to do that, every element in the second set has a pre-image, and therefore it is onto. So we're going to do a question on it. The question says, show that the function f defined from n to n, which means the domain is set of natural numbers and the codomain is also set of natural numbers. First set is the domain, second set is the codomain. And the function is defined by f of x is equal to 2x. We got to prove that it is 1 1 but not onto. So if I want to prove that it is 1 to 1, I'm going to say, we discussed it already, we will say that f of x1 is equal to f of x2. You assume that f of x1 and f of x2 are equal for some x1 and x2 taken from the set of natural numbers. So let f of x1 be equal to f of x2. What does that imply? F of x is 2x. So what will be my f of x1? 2 times x1. What will be my f of x2? Replace x by x2. So that will be 2x1 is equal to 2x2. And if I cancel, I get x1 is equal to x2. And if x1 is equal to x2, then I'll say therefore f is 1, 1. So f of x1 is equal to f of x2 implies that x1 and x2 are the same, and therefore f is 1 to 1. Now we need to prove that it is onto. Let's look at the range of f. What's the range of f? It's the set of all even natural numbers. And how do you know that it is even natural numbers? Because it is 2x. Every number is being doubled. Therefore, the range of f is the set of even natural numbers. While the codomain is the set of all natural numbers. And you can see that the codomain and the range are not the same, and therefore f is not onto. So definitely it is not bijective because it is injective but not surjective, therefore not bijective. Look at another question here. Prove that f defined from R to R given by f of x is equal to mod x plus 5 is. So I need to prove that this function is not bijective. F of x is equal to mod x plus 5, not bijective. So think about it. Why do they say that it is not bijective? Maybe it is not 1, 1 or it is not onto. How about 1, 1? 1, 1 means no two x values should have the same image. Then in that case it would be 1 to 1. So I'm thinking of numbers which can give me the same answer. It's modulus. So why don't you think of a negative number and the corresponding positive number? So I'm going to consider negative 2 and 2. So f of 2 is modulus of 2 plus 5, which is 7. And also f of minus 2, if I find, I get the same answer. So f of 2 and f of minus 2 are the same. So 2 and minus 2 gives me the same answer, and therefore it's many to 1. It's not 1 to 1. F is many to 1. F is not 1 to 1. Therefore it is not injective, and therefore it is not bijective. So we proved that it is not bijective. Now just out of curiosity, I just want to check if f is onto, which is not required according to the question, but we are going to check. Think about onto. When do we say it is not onto? If the second set, which is the codomain, and the range are different, then it is not onto. Okay, so the range of f is the set of all real numbers greater than or equal to 5. But can you look at the logic behind saying that? How can you ever say that the range is greater than or equal to 5? Because your function has a mod x. Modulus of x, the least value it can take is 0, because absolute value changes everything into positive, or if it is 0, it remains 0. So 0 plus 5, the least value is 5, or it's going to be bigger than 5. While the codomain is the set of all real numbers. So the range is going to be 5 and above, and the codomain is the set of all real numbers, and therefore f is not onto. Anyway, the given function is not a bijective function. Yeah, this is not actually necessary to do here. It's good if you do it, but it was enough to prove that it is not 1 to 1 and therefore not bijective.